Hello, everyone. Welcome back to Maths Zone African Motives. We are still on our revisions as we are working on our March preparations. All right. We are going to consider this one as a revision. That was March 2025 test, which was written as a common assessment task for KZN province. So we were given this 75 marks and 1.5 hours. So you must consider that when you're attempting your questions. All right. So I'm not going to waste your time, guys. Make sure that when you're answering question papers, go through the instructions that you are given, especially on rounding off your answers to 2 decimal places unless stated otherwise. And also, if you want to download the question paper, just check the description of the video, or you can check in the comment section. I'm going to pin a comment where you can be able to download the question paper and the memo so that you can also look into other ways how to answer these questions. All right, I might show you another way, but there are so many ways of answering. So what you need is to understand and work out as many questions as you can. So let us consider answering our questions now. Given question 1.1, you're given that if x is an element of these values, that is, we can take any of these values to represent x. Choose the value of x. Take note here. The question is you must choose. Let's be careful, guys. Choose the value of what? Of x from the given set that will make the expression x minus 5 under the square root. That is the square root of what? X minus 5 be, all right, rational. It can be irrational. It can be non-real. All right. So to answer this question, guys, as you are told that you need to choose what? The value of x. Simply substitute the values of x that you are given here, all right, into this expression. So we are given, let's take for x is equal to 0. If x is equal to 0, we are going to substitute that 0 in place of x, all right, so that we see what we're going to have at the end. We are going to have the square root of x. Our x is what? That's a 0. All right, let me just use this one to represent x. So this is going to be what? 0 minus 5, which is equal to the square root of 0 minus 5, that is minus 5. Can you simplify the square root of minus 5? That is impossible. It is impossible. This is what? Non-real. We cannot determine its value. So this is what? Non-real. So you can see that where x is equal to 0, our answer is going to be what? Non-real. So this one, the non-real, it is occurring if x is equal to what? If x is equal to 0. The question here is choose the value of x. So if x is what? It's 0. Our answer is going to be non-real. All right, let's move on. If x is equal to what? 7. Our x is 7 this time. So let us substitute into our expression the square root of what? X is 7. So this is going to be 7 minus 5, which is equal to what? 7 minus 5, that is 2. So it's going to be square root of 2. So guys, the question is, can you determine the square root of 2? Yes, we can determine this using our calculator, but the value that we are going to have here is an endless decimal. This cannot be written as a fraction. We cannot have it in the form of a over b, where a and b are integers. It is impossible. So meaning to say this represents an irrational number. Square root of 2 is an irrational number. So it is obtained from what? From x is equal to 7. So when x is equal to 7, the answer is going to be what? Irrational. So that is this one, irrational for x is equal to 7. Then let's move on to 9. Substitute this one when x is equal to what? To 9. That was going to be the square root of our x is 9. So it's going to be 9 minus 5. All right, 9 minus 5, that is what? 4. So that's the square root of 4, which is 2. 2 is a whole number, an integer. We can write it as a fraction, 2 over 1. So this is what? A rational number. All right, so when x is what? When x is 9, we are going to have a rational number. So the question there was to choose the value of x. So when x is 9, it's rational. Irrational for x is 7. Non-real for x is what? For x is 0. All right, so that was it. Just a simple task that you were given there. Between which two consecutive integers does the square root of 170 lie? On 1.2. Show all all working details, without the use of a calculator. All right, so this is it, guys. The square root of 170 is going to lie between which two? So you check 170 is not a perfect square. So what is the perfect square before 170? Just before that, a perfect square, there is 169. What about after 170, as you are working with the perfect squares? There is 196. So these are the perfect squares that surround or that make this 170 in between. So they surround 170. 169 as the smaller one. Square root of 169, and this is going to be square root of 196. So meaning to say the square root of 170 is going to lie between the square root of 169. We know that because we're choosing what? Perfect squares. So we know that this is going to give us what? An integer. The square root of 169 is 13. The square root of 196 is 14, just like that. So meaning to say the square root of 170 lie between 13 and 14. Those are the consecutive integers. All right, so guys, you are being told that do not use what? A calculator. But this is it, guys. Exam, you cannot say you are told not to use a calculator, then you restrict yourself like that. You can do this, and definitely no one is going to know that you have used a calculator there. You can find it. The square root of 170 is what? All right. 13, 0.08, and so which is 13,04. The square root of 170 is 13, what? 04, all right? Let us just take it like this. So this is what you do. You write this one aside, then you ask yourself, all right, this is the number that I'm having. So what are the integers between this decimal that we are given? What are the integers that are consecutive? All right, 13,04, guys, it is above 13. It is above 13. So meaning to say before 13,04, there is a number which is what? Which is 13, an integer. And after 13,04, there is a what? A number also, which is an integer after that, consecutive, which is what? Which is 14. So this is what you do. You are just writing this aside. You do not show it as you're working because you're told not to use what? A calculator, but you just want to cheat the process. So this is what you do. 13 is the integer and 14 is the integer. These are the integers actually that are surrounding this 13.04. So these are your answers, but you want to show the calculation now. So this is what you simply do. You take that 13, because here we are dealing with what? The square root of a number, so it must be a perfect square. So 13, you simply square it. 13 squared is what? 169. So you know that this is going to be 169. What about 14 squared? That is 196. So you know that this is 196. So this is not to be shown. You're not supposed to show that. So you know that these are your perfect squares, which we simplified before and gave us a 13. And this one, what? A 14. So you're just showing this now. You can do that even though you're not allowed to use what? A calculator on this one. But guys, you cannot let 2 marks like that if you do not know how to answer it direct. Find other ways of doing it which do not suspect anything. All right, simplify the following fully. What is that we are supposed to do? We check according to the question. Here there are 2 brackets. So definitely they want us to what? To expand them. To expand these brackets. 1.31. We have got x minus 2y into x squared plus 2xy plus 4y squared, like this. So to expand, we are going to use or let the first bracket here as it is multiply everything in the second bracket. So this is what we're going to do. X, all right, this is x. It is going to multiply every term in the second bracket. So meaning to say, this was going to give us what? X times x squared. You simply add the exponents. So 1 plus 2, that is 3. X to the exponent of 3. X times 2xy. So x and x is going to give us what? X squared. So that's 2x squared y. Then x is going to multiply 4y squared. So in that order, it's going to be plus 4x y squared. All right, you're done with x. It has multiplied everything. And we also have to maintain the same order. The number followed by a variable, which is x, followed by what? Followed by y. So it's going to be xy like that. So we move on to 2, which is actually minus 2y. So it's minus 2y times x squared. So that was going to be negative 2. Then we're going to have x squared y. All right. We move on, minus 2y times this, 2xy. So positive and negative, that was going to be negative 4x y times y is going to give us what? Y squared. All right, then we move on to the last part, minus 2y times 4y squared. So that is going to give us a negative. All right, negative to positive, that's a negative. 2 times 4, that's 8. Y times y squared, that's y to the exponent of 3. You simply add the exponents since we have got same bases. Then collect the like terms. All right, x squared y. This one, there is also x squared y here. 2x squared y minus 2x squared y. That was going to cancel. 2 minus 2, that's a 0. 4xy squared minus 4xy squared. These are like terms. So 4 minus 4, that's a 0. So those we're going to cancel. And you remain with what? X cubed minus what? 8y cubed, like that. So this is what you were going to have at the end. So it's just about revision, guys. Let us do as many questions as we can. All right, let us move on to another part. 1.32. You are being asked to simplify again. So this is also part of our brackets. 5 minus 4x squared simply means we've got 2 brackets here. 5 minus 4x. There's another one, 5 minus 4x. So meaning to say we can simply expand using our FOIL method. So 5 is going to multiply everything in the second bracket, minus 4 everything in the second bracket. So those are the terms that we are going to use. All right, just like this. So let us multiply. We're going to start with 5. So that's 5 times 5, which is 25. 5 times negative 4, that's negative 20x. All right, we are done with 5. Then negative 4 multiplies 5 here. That's negative 20 again, negative 20x. Then it's going to be minus 4x and minus 4x. So negative, negative, that's a positive. Sorry for that. 4 times 4, that is 16. X times x, that's x squared. So we collect the like terms. In our case, we have got negative 20x and negative 20x. These are like terms. So that was going to give us 25 minus 20 minus 20. That's what? Minus 40x plus 16x squared. You are done. So that is how it can be like. All right, you can even use your calculator, guys. Minus 20 minus 20 like this, that's minus 40. So it's going to be minus 40x. All right, so easy expansion, or you can simply use the concept a minus b squared is equal to a squared minus 2ab plus what? B squared, and expand it in that manner. Still, you're going to have the same answer on that one. 1.33. Simplify this. We've got fractions there. All right, so let us see. That's 3 over x squared minus 9 plus 2 over x minus 3 plus, oh, sorry, that's a minus this one, minus 1 over x plus 3. All right, x squared minus 9, that's a difference of 2 squares from our a squared minus b squared, which gives us what? A minus b into a plus b. Difference of what? 2 squares. 9 is same as what? 3 squared. So that is same as a squared minus b squared, where our a is going to be what? X, and our b is going to be 3. So it's x minus 3 into x plus 3. All right, plus 2 over x minus 3 minus 1 over x plus 3. So we can simplify this by finding the LCD of the given denominators. All right, so we have this denominator and also here x minus 3, x plus 3. These two, they are actually found in the first fraction. All right, so what we can do is to simply apply these brackets that we have on the first fraction as our LCD. X minus 3, x plus 3. So let's divide this one to the denominator. As you can see, guys, everything was going to cancel and you remain with 1. 1 times 3, that is what you're going to have. So that's going to be 1 times 3. All right, 3 times 1. 3 times 1. All right, you've got plus 2. All right, this. So let's divide this into x minus 3. X minus 3 and x minus 3 was going to cancel. So you remain with what? X plus 3. So you're going to multiply here to x plus 3. You remain with x plus 3. All right, minus 1 times this into this. X plus 3 and x plus 3 was going to cancel. You remain with what? X minus 3. So this is what you're going to remain with. All right, just like that. So by doing this, guys, we can expand the brackets as we have the terms outside of these brackets. So we can simply distribute. You're going to distribute this. 3 times 1, that's a 3, plus 2 times x, that's 2x, plus 2 times 3, that's going to be positive 6. All right, negative 1 times x, that's going to be negative x. Negative 1 times negative 3, negative, negative, that's a positive. So it's going to be positive 3 over the brackets x minus 3 into what? Into x plus 3, which we can simplify by what? Collecting the like terms. Where we have got x, we are going to collect these terms, 2x minus x. So what are we going to have on this one? That's 2 minus 1, which is 1x. So that's simply x. Then we have got the constants here, 3 and 6, and also have a 3. So we're going to add these, all right? So that's going to be 3 plus 6, which is 9. 9 plus 3, which is what? Which is 12. Everything over the given denominator x minus 3 into x plus 3. So this is it. As we can see, the numerator cannot be factorized, and we do not have anything common between the numerator and the denominator. So simply, you are going to leave your answer like this. So that is how it can be like, all right? So this is it. This is it, just like that for 4 marks, all right? So that was it, guys, as we can see. All right, so let's do revise. There are so many ways that you could have done it. So that is why I said, please do check also with the memo. Other ways that you can actually use to simplify or evaluate these. 1.34, we are given, that's 10 to the exponent of 2x plus 3. All right, let me just change this font a little bit. All right, sorry for that. So this is 1.34. 10 to the exponent of 2x plus 3 times 4 to the exponent of 1 minus x, everything over 25 to the exponent of 2 plus x. All right, so this type of equation, you can easily simplify it by writing the given bases as actually in a simplest form. You can have those ones in a simplest form. And we know that writing numbers in simplest form means you are working with what? Prime numbers, exactly divisible by 1 and itself. So 2, in this 10, do we have prime numbers? Numbers that you can multiply, then you obtain 10, but they are prime numbers, meaning to say we are actually dealing with what? Prime factors of 10. All right. So if you do not know this, your calculator is going to help you. This is what you do. You press 10. All right. 10 is equal to. All right. Then this is what you do. You're going to press shift, then fact. This B here, this fact. So it's shift, you press fact. It's going to give us what? 2 times 5. So 10 is the same as 2 times 5 in the simplest form. So you can even just use 2 into 10, that is 5. 5 into 5, that is 1. 2 times what? 2 times 5. Raised to the exponent of 2x plus 3. All right, times 4. So actually 4, guys, we know that's 2 times 2, which is 2 squared. Or you can use your calculator. 4 is equal to, then shift, fact, 2 squared. So 4 is the same as 2 squared raised to the exponent of 1 minus x. And this is over what? 25. 25 the same, you can do the same thing. 25 is equal to, then shift effect, 5 is squared. So that's 5 squared, 2 plus x. So this is what you have from rewriting these numbers in simplest form. So the simplest form must be having prime numbers. Prime numbers. All right. Using our laws of exponents, we can see that on the first part, we have got 2 numbers being multiplied and raised to a certain exponent. So it follows that if A and B are raised to the exponent of n, each term will be raised to that exponent n. A to the exponent of n times B to the exponent of n. Every term inside the bracket. So this is the same thing that we have here. So 2 is going to be raised to the exponent of what? 2x plus 3. And 5 is also going to be raised to the same exponent, 2x plus 3, separated by multiplication. They're being multiplied 8 times. All right? On this part, there's an exponent to another exponent, x raised to the exponent of m and raised to the exponent of n is going to give us x to the exponent of mn. You multiply the exponents together. So that's an exponent. You just simply multiply 2 times this. That's going to be 2 to the exponent of 2. 2 times negative x, that's negative 2x. Everything over, this is the same here for this 5, guys, as we can see. So it's going to be 2 times 2, which is 4. 2 times x, which is what? Which is 2x. So this is where we are. We have applied our laws. And again, at this stage, we are supposed to apply the laws. As we can see, 2 is separate, another 2 is separate. There's a 5 here, there's a 5 here, which are separate. So we can consider the laws under multiplication of same bases. X to the exponent of m multiplied to x to the exponent of n. Same basis, you simply add your exponents, m plus n. When it is a division, you subtract m minus n. So this is what is exactly happening here. 2 times 2, these are same bases. You are multiplying this to this. Add exponents. So you're going to add 2x plus 3 to this exponent plus 2 minus 2x. All right, when adding, there is no need of you opening a bracket, guys. Just write as it is, all right? The bracket, yes, you can put it, but it is important when it is under a subtraction, all right? So if you consider the base of what? Of 5. It is the same base here, the base of 5. But it is under a division. This one in the numerator, this one in the what? Denominator, a division. So what do? You subtract, just like what we have here. So that was going to be 5 to the exponent of 2x plus 3 minus, this is what I'm saying, guys. For a subtraction, it is very, very important that you put the brackets to show that the negative is going to affect everything. 4 plus what? Plus 2x. So this is it. Addition, there's no need of that. You could have just put the brackets, no problem. So that you do not confuse to say, where do I put brackets? It's not a problem. Still, you're going to have same answers for an addition, all right? So this is where you are. Simplify these exponents, all right? So as you can see, this was simply going to be 2x plus 3 plus 2x minus 2x. 2x minus 2x, that's a 0. So you're left with what? 3 plus 2. 3 plus 2 is what? 5. So that's 2 to the exponent of 5 times. This here is going to give us 2x plus 3 minus times 4, that's minus 4, minus times 2x, that's minus 2x. So as you can see, guys, 2x minus 2x cancels. 3 minus 4, that's negative 1. That's a negative 1. So this is where you are. And we can simplify further. 2 to the exponent of 5. You're multiplying 2 5 times 2 times 2 times 2. So that's what? That's 32. All right, times 5 to the exponent of 1 simply means 1 over 5. Remember that. So this is a product, guys. You multiply the numerators together, the denominators together. So meaning to say 32 times 1, that is 32. Over 1 times 5, that's a 5. So this was going to give us 32 over 5, just like that. All right, so yeah, it can be like that. Just make sure that you revise your laws of exponents. Every part you answer using a law. Every part you have to apply the laws. So revise your laws, all right, from your grade 9 up to your grade 10. All right, let us move on to 1.4. There we are being told to factorize the following expressions fully, all right, or completely. 1.41, that's 2x squared minus 18. These are just two terms. It's not a difference of two squares originally as it is, but there is a highest common factor. So use the golden rule, factor out the highest common factor. So the highest common factor here between 2 and 18, that's what? That's a 2. So 2, you factor it out, 2x squared divided by 2, that's x squared. Minus 18 divided by 2, that's a negative 9. What we have inside this bracket, guys, it is a difference of two squares. X squared, a perfect square, 9, a perfect square. So that's we can apply our difference of two squares. All right, 9 is same as what? 3 squared. So meaning to say we've got x and what? X and 3. So that's x minus 3. Another bracket is gonna what? Is gonna add. Or simply the square root of x squared is x. The square root of 9 is 3. One subtracts, another one it adds. Or you can start by addition. It's not a problem at all. 1.42 again, factorize 8 plus 125a cubed. All right, are we seeing that this is a sum of two cubes? Sum of two cubes. 8 is a perfect cube. The cube root of 8 is what? The cube root of what? The cube root of 8 is 2. So meaning to say this 8 that we see is the same as 2 to the exponent of 3. Plus 125 also is a perfect cube because we can determine its cube root. Cube root of 125 is what? Is 5. So this is same as 5a to the exponent of 3 because this was supposed to be 5 to the exponent of 3. A to the exponent of 3. So remember the concept, guys. Raised to the same exponent. We can simply use that exponent outside. All right? So that's an easier way. That's to the exponent of 3. So meaning to say, from our factorization, remember when you are factorizing this sum of two cubes, a cubed plus b cubed is equal to a plus b into what? A squared minus ab plus b squared. The first term being a, the last term being b. So this is our a and our b from this concept. This is our a, this is our b. So this is going to give us what? A plus b, meaning to say we simply add these two, a plus b. This is your a, this is your b. So a plus b, that's 2 plus what? 5a in a bracket. Into what? A squared, a being our first term, which is 2. So 2 squared is 4. Minus ab. So you're going to subtract ab, a times b, which is 2 times what? 5a. Our a is 2, our b is 5a. So this was going to give us 10a. So that's minus 10a. Then plus b squared. The last term b is what? Is 5a, but it must be squared. So 5 squared is what? 25. A is also squared. So that was going to be plus 25a squared in bracket. Just like that. So guys, I have introduced these topics. So please go through the introductions, all right? So that it won't be like something that is new. This is not new. If you've been watching our videos, from the introductions, I have introduced these. So go through that so that you can understand much better. 1.43, they are giving us here, actually they gave us 4 terms. These are 4 terms. 1, 2, 3, 4. So we know that when dealing with 4 terms, we're going to do this one by what? By grouping. By what? By grouping. So we can do this by grouping into 2 terms. The first 2 terms, is there anything common? For the last 2 terms, is there anything common? Yes, for the first 2 terms, x squared is the highest common factor. So you're going to factor out x squared. So meaning to say you're going to have x cubed divided by x squared, which is x. Minus 2x squared divided by x squared is going to give us minus 2. Minus 2x squared over x squared. This is going to cancel. So you remain with negative 2. In these, for these last 2 terms, 5 is common. That's our highest common factor actually. So you factor out plus 5. 5x divided by 5, that's x. Minus 10 divided by 5, that's minus 2. So this is it. By grouping, you're supposed to have 2 brackets which are exactly the same. So those two brackets now, you factor them out, or you factorize, you factor that x minus 2, you factor it out. Meaning to say, when you factor out x minus 2, you remain with x squared. That's another bracket. If you factor out x minus 2 here, you remain with what? Plus 5. So this is what you're going to have at the end. And this cannot be factorized further. This cannot be factorized further, meaning to say you are done on your factorization. So it's all about revision, guys. You just need to do more revision that can help. Let us consider this was 1.5, and we were given that if, all right, take note of these statements. These statements, like if this is equal to this. Once you're given that if this is equal to something, they want you to use that on your calculations. They want you to include that statement that you're given, that 2 to the exponent of x is the same as what? Is the same as 3. So what you're supposed to do is to make sure that on your simplification, you rewrite these statements as, or in terms of what? What you are given 2 to the exponent of x. They want you to include that statement if this is equal to this. So our major part here is to obtain 2 to the exponent of x from what we are given. How is that possible? All right, let's check the first one. 1.51, 2 to the exponent of minus x. Guys, this is not 2 to the exponent of x. This is positive here. It's positive. So we must get rid of the negative. Remember, x to the exponent of minus n is 1 over x to the exponent of n. So this is the same as 1 over what? 2 to the exponent of x. Are we seeing it? Are we seeing that 2 to the exponent of x? The one that we got here. It's clear now. So in place of that, because you're already told that these two, they are equal. You're already told, you can now replace it with its equivalent, which is what? Which is 3. It is equal to what? It is equal to 3. Numerically, we want numerical values. So it is over what? Over 3. Just like that. You're done. You're done. What you need is to see that 2. Once you have it, this 2 to the exponent of x, you're done. Once you have it, then you can substitute. All right, let's check another one. 8 to the exponent of x. All right. What we need is what? 2 to the exponent of x. So how can we obtain that? 8 is the same as 2 to the exponent of 3 in the simplest form. Raised to the exponent, there's also what? X there. So it's 2 to the exponent of 3x. We are not properly seeing this 2 to the exponent of x, guys. But it is there here. 2 to the exponent of x, it is there, this one. So we can rewrite it as 2 to the exponent of x. But what? Raised to the exponent of 3. To the exponent of 3. This is what it means. It's the same, guys. 2 to the exponent of x to the exponent of 3. 2 to the exponent of 3 to the exponent of x, like this. It's one and the same writing. We haven't changed anything. What we just need is to properly see this 2 to the exponent of x so that we can substitute with its equivalent, which is what? Which is 3. So this is the same as 3 raised to the exponent of 3. 3 times 3 times 3, which is what? 27. Just like that. So this was going to give us a 27 direct. All right, let's move on to another one. 1 over what? 1.53, 1 over 16 to the exponent of x. All right, 1 over 16 is the same as 16 to the exponent of -1, if we are to reverse here, raised to the exponent of x. All right, so 16, can it be written in the base of 2? Yes, it is the same as 2 to the exponent of 4. But raised to the exponent, there will be 4 times negative 1, which is what? Negative 4 to the exponent of x, this one. So this is the same, just like before. Remember what I said. Remember what I said? What we need is 2 to the exponent of x, which we can see here. So it is the same as 2 to the exponent of x to the exponent of what? Negative 4. One and the same. We haven't changed anything. What we just want is this, 2 to the exponent of x, which we know it is equal to what? It is equal to 3. So in place of that, we are going to put 3 to the exponent of what? Negative 4. So we can simplify further, guys. Remember, x to the exponent of negative n is 1 over that. So this is 1 over 3 to the exponent of what? Of 4. So that's 1 over 81. 3 to the exponent of 4, that's 81. 3 times 3, we multiply it 4 times. All right. So that is how these questions can be given or can be calculated as. So all you just need is to do more revision, all right, just to understand how questions can be given as. Moving on to question number 2, 2.1, you're given solve for x. 2.11, two brackets are given, two terms are given, 3x into x minus 8 is equal to 0. That's a zero product. Remember, a times b to be equal to 0. A must be equal to 0 or b must be equal to 0. So that's 3x can be equal to what? Can be equal to 0, or x minus 8 is equal to 0. So let us solve for x here. Simply divide by what? By 3. So x is equal to 0, or x is equal to what? Minus 8 to the other side, that is going to be a positive. All right, or simply add 8 both sides. So 0 plus 8, that's what? 8. So these are the values of x that you're going to have from this part. All right, so that was a little bit direct. Let us move on to another one which needs our factorization. All right, 2.127 x squared minus 5x minus 2 is equal to 0. So you can simply try apply our factorization method. All right, so on your factorization, guys, I am not going to limit you to my method. There are so many methods that you can use. So I'm just going to apply the cheat method. Remember, we talked about the cheat method on a separate video. Check, is it grade 10 or grade 11? But I explained that one. This is what you simply do. You take the first term, multiply it to the last, which is our constant. All right. So you multiply it to the constant 7 here. So it's going to be removed. All right. So it will be x squared minus 5x minus 7 times 2, that's minus 14. The reason is we can factorize this one direct if the coefficient of x squared is what? Is 1. We simply put x and x here. X times x is x squared. And you can consider what? The factors of negative 14, which adds up to negative 14, negative 5. Factors of negative 14. But these factors must add up to 5. Factors or products of negative 14. There are so many, guys. Negative 14 and 1, 14 and negative 1, negative 7 and 2, 7 and negative. There are so many. But of these, which part, when you add, you're going to get negative 5? It is between negative 7 and 2. If you add these two, you're going to get a negative 5. Negative 7, negative positive 2. This one is what? Positive 2. So remember, we had to remove the 7, so we bring it back in place of x. Remember, it's from x squared. So you put it in place of x, that's 7, you put it back. Also here, you put it back. Then factorize where possible. All right. In the first bracket, 7 is common. So we are going to factor it. 7x to 7, that's x, minus 7 to 7, minus 1. And this second bracket, nothing is common. We do not have highest common factor. The 7 that we factored out is useless. It is not part of your solution. These are the answers, the brackets that you need on your answer. These two brackets. X minus 1 into what? 7x plus 2. So like I said, guys, factorizing this one, there are so many ways. Please choose or work out the way that you understand. But at the end, you are going to have what? Two brackets like this. So from these two brackets, you can solve for x both. Remember, we are back to the product of two terms equal to 0. So it means either x minus 1 is equal to 0 or this bracket of 7x plus 2 is equal to 0. So you can solve for x. Minus 1 to the other side, that's a plus. So it's going to be plus 1. Or here take the 2 to the other side is going to be a negative. 7x is equal to minus 2 divided by 7 by 7. So that's x is equal to minus 2 over 7. So that is it. These are the solutions that you're going to have, the values of x that you are going to have at the end. All right, so that was 2.12. 2.13, again, we have to solve the equation. Solve for x. Given that, all right, 2.13, given that 3 to the exponent of 5x minus 4 is equal to, sorry, that's minus 729, but I'm just going to take it to the other side. So it's going to be positive 729. So the reason why I had to take this one to the other side of the equation, it is because of the bases. We can rewrite these bases in the same base. Since they are different, we can have them in the same base. The reason being, if x is raised to the exponent of a is the same as x to the exponent of b, as long these bases are the same, it means the exponents automatically are the same. A is equal to b. So this is what we want. As long we can have same base. So 3 is already a prime number, so it is in a simplest form. There is no way we can rewrite it as another number. But 729 is not a prime number, so we can rewrite it as what? 729 is equal to what? Then shift, you press fact. 3 to the exponent of 6. As long this happens that the bases now are exactly the same, automatically, guys, your exponents are the same. So therefore, our exponent 5x minus 4 must be equal to what? To 6. You can solve this. You are used to these type of equations. That's a linear equation. So how do we solve for x? Get rid of the negative 4. Simply add 4 both sides. So that's 5x is equal to what? 6 plus 4, that's 10. So to get the value of x, simply divide by what? By 5 here. So x is equal to what? To 2. All right? Just like that. So this is what you have. X is equal to 2. So that was 2.13. 2.14, again, we are to solve for x, and this is given as 2.14, 2 to the exponent, sorry, that's 2x to the exponent of minus 3 over 2 is equal to 128. All right, where the exponent is a rational number and you want to solve x as the base. All right, just get rid of this 2. It's a product. There is no need of us to get hold of this. Simply divide by what? By 2. So x to the exponent of minus 3 over 2 is equal to what? 128 divided by 2, that's 64. So remember the process that when you've got a rational exponent, simply find its reciprocal. The reciprocal. All right, sorry. So you're going to need the reciprocal of that, which is 1 over this, the reciprocal of the exponent, 1 over minus 3 over 2. From your calculator, that's minus 2 over 3. So you raise or you simply multiply this to the exponent of what? Negative 2 over 3. This one, you raise it to the exponent of negative 2 over 3. So that this simply neutralizes and gives us what? A 1. And on the right hand side, you must simplify. Remember, 64 in simplest form, that's 2 to the exponent of 6. All right, 2 to the exponent of 6 raised to the exponent of negative 2 over 3. So remember, guys, exponent, I've already explained this law. You multiply them together. So 6 times negative 2 over what? Over 3. That's a negative 4. So this was going to give us a negative 4. 2 to the exponent of negative 4. How do I get rid of a negative exponent? I introduce 1 over 2 to the exponent of what? 4. So this is x is equal to 1 over 2 to the exponent of 4 is 16. You're multiplying 2 4 times. So that was going to give us 1 over 16 at the end. All right, direct like that. It is just a matter of revision, guys. That was 2.14. Let us quickly check 2.15, which is a little bit, all right, a lot, because that's 5 marks compared to what we just had. All right, that's 2.15. 2 to the exponent of x plus 1 plus 2 to the exponent of x minus 1 is equal to 20. All right, there we can play around with our laws. Remember, this simply means you were having same base of 2, which we can just multiply 2 to the exponent of x times 2 to the exponent of 1 plus 2 to the exponent of x times 2 to the exponent of what? Negative 1. And that's equal to 20. All right. We do understand that here we can just factor out the 2 to the exponent of x, which is common. Actually, it is a common term that you have. So you can simply factor it out as we are under addition. So this can be factored out. 2 to the exponent of x. You are going to remain with 2 to the exponent of 1, which is 2, plus 2 to the exponent of minus 1, which is same as 1 over 2. 2 to the exponent of 1 over this. So that's equal to 20. So what you're going to do here is to divide by the bracket, or you can just simplify it. What is inside the bracket? 2 plus what? 2 plus 1 over 2. That's going to give us 5 over 2. So that's 5 over 2, which is equal to 20. So you can get rid of that 5 over 2. Simply divide by what? 5 over 2. Simply divide by what? 5 over 2. So this was going to cancel. And you have got what? 2 to the exponent of x, which is 20 divided by 5 over 2. That's the same as 20 times. You invert the second fraction, so it's going to be 2 over 5. So that's 1, a 4. 4 times 2, that's 8. Or just use your calculator. 20 divided by what? Open bracket, 5 over 2. Then close the bracket. That is going to give us what? 8. Guys, where we are, I have already explained this state that we can make the same bases. We can make these 2 to be written in the same base, where 8 can be written in the base of 2 as 2 to the exponent of what? 3. Where if these bases are the same, automatically our exponents are the same. So therefore x is equal to what? To 3. Just like that. So we have solved this from what we were given. So it's a matter of play around with questions, all right? It's a play around with your questions. So that was it on 2.15 with the 5 marks, all right? Then 2.2, we are given calculate the value of b from this, all right? It is just like an equation that you're given there. Let us just try to play around. 2.2, a cubed plus 2a to the exponent of negative 3. So this is a cubed minus 2a to the exponent of minus 3 squared plus b. Calculate the value of b. All right, let's see. So this is b separate, guys. Let's just put it on one side. Let us just make it the subject of the formula. So you're going to take this to the other side of the equation. So it was going to be a negative, and you are left with what? With a b. So what I'm simply trying to say here is that b, since it is left on one side of the equation, it is equal to, you have taken this to the other side. So where we had what? A cubed plus 2a to the exponent of minus 3 squared. So you took this one to the other side. So it's going to be a negative of what? A cubed minus 2a to the exponent of minus 3 squared. This is where you are. So you simply took this one to the other side. It's going to be a negative. You are left with b. So since they said solve for b, simplifying this will give us the value of b. As we simplify this, so how can we simplify? Are we seeing that this bracket raised to the exponent of 2, and there is this bracket raised to the exponent of 2 again? Are we seeing the concept that this is simply a difference of 2 squares? A squared minus b squared. So this is our a. The whole of this bracket here is our a. This one, the whole of this bracket. That's our a squared. A squared. Then this whole bracket is our b. This one, b squared. Are we seeing that? B squared. So if a squared minus b squared truly gives us a minus b into a plus b, why can't we do the same thing? Because we have what represents our a and what represents our b. So if this was going to give us a minus b, we're going to take our a. This is our a cubed plus 2a to the exponent of minus 3. That's our a. Minus b. This is our b, but it is an expression now, so we must open a bracket to simplify that expression. That's a cubed minus 2a to the exponent of minus 3. So this is it. So this one represents a minus b. It's a bracket, this one, of what? A minus b. Into what? A plus b. So you're going to have a plus b. Our a is what? This whole part. A cubed plus 2a to the exponent of minus plus b. We are adding b. Remember, I said addition, there's no need of brackets. All right, but if you want, you can just open bracket for b. A cubed minus 2a to the exponent of minus 3. This is what we have. So that's a minus b. This is a plus b. You have affected, you have applied your difference of two squares. Now let's simplify. Are we seeing that we have to simplify everything inside this bracket? So definitely this was going to be a cubed plus 2a to the exponent of minus 3 minus times this, that's minus a cubed. Minus times minus, that's a positive. So we can collect the like terms, which is a cubed minus a cubed, that's a 0. All right, 2a to the exponent of minus 3 plus 2a to the exponent of minus 3. Those are like terms. So that's an addition. 2 plus 2 is what? Is 4. So that was going to be 2 plus 2, which is 4a to the exponent of minus 3. So the whole of this bracket gave us what? 4a to the exponent of minus 3 times this bracket. So you're going to simplify this bracket. So the sum, this is just addition, guys. So you can see that this is a cubed plus a cubed. 1 plus 1, that's 2a cubed. And 2a to the exponent of minus 3 minus this, these two we're going to cancel. So you're going to remain with what? This. This is what we have at the end. So how can we simplify this? All right, this is just a product. You can multiply the numbers together. 4 times 2, that's 8. A and A, those are same bases. So you add exponents as you multiply. So you add exponents. That was going to be 8a to the exponent of minus 3 plus 3, that's a 0. Remember, any number to the exponent of 0 is 1. So this is the same as 8 times 1, which is what? Which is 8. So B is equal to 8. Take note, what is raised to the exponent of 0? It's A, not 8. 8 is on its own. But A is the one raised to the exponent of 0. So it's going to give us a 1. Then you multiply to this 8. That was it. So you see, guys, they'll be playing around with you. That's why you must do more question papers. They'll be playing around with you. It will be something new in exam if you do not revise. So avoid these things in exam where something is actually totally new. You must be, when you're answering an exam, it is just a revision. You're saying, I have done this question before. It was just like this. All right. Given this, solve for x on 2.31, the inequality minus 2x plus 3 is greater than or equal to minus 9, but less than what? 5. So remember, when you're given this, guys, you deal with what is in the middle, this one that is separated by the two signs. These are simultaneous inequalities. So you're being asked to solve that one on what? On 2.31. All right, let's get rid of the 3 here, positive 3. So you're going to take it to this side and you also take it to this side. So it was a positive, so it's going to be negative 3, negative 3. All right, minus 9 minus 3, that's minus 12. All right, so we are left with what? Negative 2x. Remember, we removed the 3. Is less than here 5 minus 3. That's what? That's a 2. So this is what you are remaining with. And still focusing with the middle part or the middle term, which is the minus 2x. Now we have to get rid of the minus 2, which is a multiplication. So we have to divide by negative 2, divide by negative 2, divide by each and every term. But knowing that the moment you do a division, you apply a division by a negative like this, the inequality signs reverses. These inequality signs, they are affected by what? Dividing or multiplying by a negative. So meaning to say, it was according to this, looking, the sign has to reverse. So it's going to be facing this side like this. All right, negative 6, all right, negative 12 divided by negative 2, that's a positive what? A positive 6. All right, on this other hand, the inequality sign reverses again. Remember, you divided by what? A negative, so it changes. So it's going to be facing this side now. 2 divided by negative 2, that's what? A negative 1. So this presentation is not allowed. Every time x is supposed to be greater than a, it's supposed to be like this. This is a presentation that you must have. Or it can be equal to equal, but the inequality sign, they're supposed to be facing this side, not the other way. So you must rewrite now, starting with the smallest value, which is what? Negative 1. So x is what to negative 1? It is greater. Are we saying that it is facing negative 1? So you just write, starting with that one, x is greater than a, so it's greater than minus 1. But x has to be less than this value. Which value is it? Look at this. X is less than or equal to 6. X is being pointed here. So x is less than or equal to 6. We haven't changed anything. It is just that we must write in a proper way. So this is what we have. All right. But they are saying here, represent that solution that you had on 2.31 on a number line. So the number line, what is important are the critical values. The critical values, which is what? Negative 1 and 6. All right. So 2.32, we need the critical values, negative 1 and positive 6. All right. So this is going to pass through 0, which is as long as you've got critical values. So negative 1, x is greater than that. So you represent a circle. Do not shade. You only shade where there is equal to. So 6, x is less than or equal to 6. You represent with a circle that is what? Shaded on the critical values. Then you join the critical values with a straight line. That's how you represent your number line. All right. What is important are these critical values. You just show them. And where there's greater than, less than, just a second. Greater than or equal to, less than or equal to, you shared the second. All right. That is the number line concept. So that was it. Let us move on to 2.4. Solve for x and y simultaneously. All right, so you check in the memo, guys. There are so many ways, methods that you can use, and I've explained those methods on each section. The substitution, elimination, I talked about that. So you choose which method that you want. So I'm just going to use substitution method. I have got two equations, equation 1, equation 2. So by using the substitution method, I can play around with one of these equations, make x or y the subject. Make x or y the subject from any one of the equations. So as for me, I'm just going to choose the first equation. It's easier for me to make y the subject there because I simply need to take y this side. It's going to be positive, and 17 to the other side is going to be a negative. So y is the subject. All right. So I had to make y the subject. Y is equal to what? 2x minus 17. Y is equal to 2x minus 17. It's going to be my equation 3. So I made y the subject from equation 1. So this is what you do. You now substitute it in the other equation, not from equation 1, but the other one, the second one. So you're going to substitute our equation 3 into what? Into equation 2. Remember, we made y the subject from equation 1. So you must substitute into the other one, equation 2. In place of what? In place of y. Wherever you see this y here, you put 2x minus what? 17. That is what I mean. In equation 2. All right? So this is what it means for y. So it's going to be y is what? 2x minus 17. You must substitute that. Plus 3x. This one is not affected. Is equal to 9. Is not affected. So as we can see, we are just left with x only. It allows us now to solve for what? For x. So how can we solve for x? If you were given just like this, an equation just like that, you're asked to solve for x. You're going to what? Distribute here this bracket, expand it by what? By 4 throughout. So that's 4 times 2x, 8x. 4 times negative 17, that's negative 68. This part remains as it is, plus 3x is equal to 9. Collecting your like terms, you can see that on the left hand side we have got x and x, so we can collect those like terms. 8x plus 3x, so 8 plus 3 is what? That's 11. All right, so that is going to give us 11x minus what? Minus 68, and that's equal to 9. All right, solving for x, you can take this negative 69 to the other side. That was going to be a positive. 11x is equal to what? Simply add 68, 68 both sides. So 9 plus 68, all right, it's going to give us 77. That's 77 here. So you can determine the value of x by simply dividing by what? By 11. So x is equal to 7. This is what you have. That's the value of x that you're going to have from here. So to find the value of y, guys, it's easier for us to use equation 3, because already in equation 3, we have y as the subject there, 2x minus what? 17. So where x is what? 7. You can simply put it there, 2 times 7 minus 17. In place of what? In place of x, you simply put 7. So that was it. That's a substitution method. 2 times 7, that's 14, minus 17. So y was going to give us a negative 3 at the end. So that's it. X is equal to 7 and y is equal to what? A negative 3. So please, guys, do revise. Do revise. Work out as many questions as you can. It's all about revision. And like I said, this is not the only way or the only method. You could have made X the subject of the formula if you are comfortable with that. From any equation, it's your choice. But at the end, you must have same answers. You can also use elimination method. All right? So apply the method that you understand. All right? Apply the method that you understand and verify your answers if they are the same. It is very, very important to verify. So let us consider question number 3. There we are given 3.1 in the diagram below. We have got triangle PQR, which is right angled at Q, as Q is what? 90 degrees. Angle P is theta, all right? So angle P is given as theta. And PQ 5 units and PR 13 units, all right? So that was the information that we had on our diagram. And the questions were 3.11, determine the numerical value of AQR, all right? So QR, that is this one. All right, so we can simply use our Pythagoras theorem there to calculate QR. Remember that the hypotenuse squared, which is PR squared, is equal to the square, the sum of square of these two shorter sides, which is we are going to consider the two shorter sides, PQ squared plus QR, this one squared. All right, the sum of squares of what? The two shorter sides. So we have PR, which is 13. So that's 13 squared is equal to PQ, which is what? 5. So that's 5 squared plus QR squared. So you're going to be left with QR there. 13 squared, that's 169. 5 squared, that's 25. Plus QR squared, and we're going to take the 25 to the other side. So that's 169 minus 25 is going to be a negative, and that gives us 144 equal to QR squared. And to find QR, simply introduce the square root. So that's 12 is equal to what? QR. So this is the length of QR, which is 12 what? 12 units. All right, so our QR is there, guys. That's 12 units. All right, so that was the part A of 3.11. Then part B, the cos of theta. All right, so that's the cos of theta. So remember from our soccer tour concept, the cos of theta is adjacent over hypotenuse. So according to theta, this is our opposite. All right, this is adjacent. Theta and 90 degrees, they are adjacent to each other, and that's our hypotenuse. So as we need adjacent, which is what? 5, over the hypotenuse, which is what? 13. So that was going to be 5 over 13. Then moving on, C, the cot of theta. All right, so the C, the cot of theta. Remember, cot is taken as the reciprocal of what? Of tan theta. So you can find the tan of theta on its own if you want. The tan of theta is what? Opposite over adjacent, opposite over adjacent, which is opposite is what? Is 12 over adjacent, which is 5. So 1 over, that's cot now, 1 over the tan, which is what? The reciprocal of this, 12 over 5. So what is the reciprocal of 12 over 5? Simply invert the fraction in the denominator. So it's going to be 5 over 12. So that was the cot of angle theta. All right. Or simply if it is the reciprocal of what? Of a tan, and we know that tan is opposite over adjacent. So it means the chord is going to be the reciprocal adjacent over opposite. So adjacent is 5 over what? Opposite, which is 12. So that's a chord, the reciprocal of what? Of a tan. So these were worked out from the angle theta. But the part D, it is not about angle theta, it is about angle QRP. So according to angle QRP, this information changes. QRP, we are now referring to this angle here. This is angle QRP. This 5 becomes your opposite. They are facing each other. So that's opposite this time. 12 is the adjacent. Angle R and Q and 90 degrees, they are adjacent to each other. The hypotenuse is not affected. It remains as it is, always facing what? 90 degrees. So the size changes according to the angle that you are referring to. So the sec of angle QRP, according to this, remember sec is 1 over cos. So it simply means 1 over cos QRP. All right, where we can determine that cos QRP. All right, cos QRP according to our ratio of cos adjacent over what? Hypotenuse. So QRP adjacent is what? Is 12. And hypotenuse is 13. So it means 1 over this, that's 1 over 12 over 13. Which is the reciprocal. Just interchange this. So it's going to be 13 over 12. So that's what you're being asked there. All right. So many ways that you can actually use or apply. Just do revise as much as you can. All right. Then moving on to another part, which is 3.12. Write down the trigonometric ratio. Take note what they want. They want the trigonometric ratio that is equal to QR over PR. All right? QR over PR. So, guys, to have this trigonometric ratio, you must consider these two angles. It's either angle R or angle theta. All right, let's start with angle R since it is the one that has got these sides that I've already named here. According to, so this one is according to angle QRP. According to angle QRP. QR represents what? According to this, QR over PR. According to this angle QRP, the side QR represents what? This is our QR, this one. It represents the adjacent. So this is the same as we've got adjacent over what? PR. PR represents the hypotenuse. So which ratio, guys, gives us adjacent over hypotenuse? Adjacent over hypotenuse is from what? From cos. So therefore, it is the cos of this angle, QRP, which is going to give us what? Adjacent over hypotenuse, which is what? QR over PR that you're given. So you name the sides according to the angle. This was according to angle what? QRP. So you are going to have this answer. But it is different now from someone who is working from angle theta. From angle theta, this is what you're going to have, all right? From theta. According to angle theta, this one. This is now our opposite. Remember, the sides are mentioned according to the angle. The 90 and the theta, they are adjacent. So 5 is the adjacent side. And 13 remains as the hypotenuse. So according to that angle theta now, you have to name these sides QR over PR according to theta. So according to theta, QR represents what? QR is our opposite over what? PR. PR is hypotenuse. Which ratio has opposite over hypotenuse? That's a sine. Opposite over hypotenuse. It's what? Sine of theta. So therefore, it is the sine of the angle that you took that one from, the sine of theta, which gives us opposite over hypotenuse, which is what? QR over PR. That's another answer that you could have shown, because they just want a trigonometric ratio. So our trigonometric ratio is what? Of the sine. Sine of theta is equal to that. Or you use the first one. So that was it on this one. It was a matter of play around with the question that you're given. Then 3.2, if angle A is 34 degrees, angle B 53 degrees, use your calculator this time to evaluate the following correct to 2 decimal places. All right. 3.21, the cos of B minus A. We are already told that angle B is what? Is given as 53. So that's 53 degrees minus angle A, 34 degrees. So that's it, guys. You can simply use your calculator here, or you can find the difference. 53 minus 34 is 19. So that is the cos of 19 degrees. Cos 19 degrees is what? 0.94 and this. So 5 is going to change this 4 into a 5. Remember, to 2 decimal places, or simply use your calculator, shift, set up, then you press number 6, then you press 2 to 2 decimal places. It's going to give us what? 0.95. All right. So that is how we can answer this. Then the second one, it is the sine squared of what? Of B. The sine squared of B, it is the same as the sine of B squared. The sine of that angle B squared. So that is the sine of angle B is what? 53 degrees being squared. So use your calculator, open the bracket, sine of what? 53 degrees. Close the first, this bracket here for 53. Then you must close the first one that you opened. Remember, you opened this bracket. So you must close it and raise it to the exponent of 2. So that was going to give us, all right, 0.64. Already our answer is fixed to 2 decimal places, 0.64. Just like that. All right, 3.3, which is the last part of our question. That was the last question, all right? Without using a calculator, without determining this. So here it is all about your special angles. Remember your special angles. 45, 45 is going to give us 1 square root of 2. Then there is also this triangle of 60 degrees, 30 degrees, 1, 2, square root of 3. Remember your triangles, guys. So cosec 45. Remember cosec, it's 1. Cosec 45 is going to be 1 over. Cosec, it's 1 over sine. Sine 45 degrees. But what is the sine of 45 degrees? All right, opposite, hypotenuse, adjacent. The sine of 45 degrees is opposite over hypotenuse, 1 over square root of 2. Remember, by rationalizing, it's going to give us square root of 2 over 2. So meaning to say, when I want 1 over sine 45, it means 1 over the sine of 45 square root of 2 over 2. This is what you have. All right? This is what you have. Times the sine of 60 degrees. According to 60 degrees, sine is opposite over what? Hypotenuse. So that's the square root of 3 over 2. Opposite over hypotenuse. All right? Everything over the sine of 45. Remember, we already have it here. Sine 45. Square root of 2 over what? Over 2. Times the cos of 30 degrees. According to 30, cos, that's adjacent over what? Hypotenuse. Adjacent over hypotenuse. Square root of 3 over 2. According to 30 degrees, this is our adjacent. This is our hypotenuse, and this will be your opposite. So you can simplify this. That is going to give us 1 over, remember that the reciprocal. All right, so simply change this. It was going to be 2 on top over the square root of 2 times the square root of 3 over 2, everything over what? All right, this is going to be square root of 2 over 2 times square root of 3 over 2. Are we seeing that these two guys are the same? So just cancel these two. So you're remaining with the square root, this one divided to this, which simply means 2 over square root of 2 times. Remember, at division, you introduce multiplication. The moment you do that, you interchange that second fraction. So it's going to be 2 over square root of 2. You interchange, swap those two. So that's it. We do not have anything common, so you're going to simply multiply the numerators together. 2 times 2, that's a 4. Square root of 2 times square root of 2, that's a 2. Remember, square root of a times square root of a gives us a. Or just multiply 2 times 2, that's what? That's 4. And the square root of 4 is 2. So that's it. 2 into 2, 1 into 4, that's a 2. So it was going to give us a 2. 2 over 1 is 2. So that is it. That is it for the whole question paper that we had. That is it, guys, for you to obtain 100%, which is obtaining 75 out of 75. That's how you can answer these questions. Just do more revisions, as many question papers as you can. Revise 2023 exams, 2024, because it is still the same thing, same concept. Whether it's 2023, we still have same topics in our term 1 as it is now. So those question papers, they are also important. Do not neglect them, revise them. All right, so that is it, guys. Till we meet again.